moving on to MCQs. So one look at this, and we observe that the substitution ln x by t will, I think, ease up the things. So we'll do that. Substituting here x by log x, ln 1 is 0, ln e is 1, so we get new limits. Ln x is replaced by t. We have a root t in the numerator. In the denominator we have a minus t cubed squared, and dx by x will become d ln x, which will become dt. We are given this is equals to 1. So what we did is we substituted ln x by t. So let's now look at this integral. We have integral 0 to 1 root t now what we'll do is we'll substitute t to the power of 3 by 2 as p, some variable, so the limits won't change. So this will give us tp equals to 3 by 2 root t dt. Which gives us root t dt is 2 dp by 3. So this root t dt, we will substitute this by 2 dp by 3, we will get 2 by 3 out here, and dp upon a minus p squared. So now this is straightforward. This becomes 2 by 3 into 1 upon a minus p from 0 to 1, which is becomes 2.3 times a into a minus 1 equals to 1. Okay, so now we have a square minus a minus 2, or rather we'll multiply this whole by 3. Okay, wait, let's not skip steps here. We have this, which is 3a square minus 3a minus 2 equals to 0. A equals to 3 plus minus under root of 9 minus 4 upon 6. B square is 9 minus 4 into minus 2 into the minus 6 plus 24, 19, which is so 3. So answer is C and D, because an irrational number, so this clearly is an irrational number. It satisfies the above equation, and more than one a, we have two distinct a's for which this equation is true. So answer is C, comma D. So after this substitution, it was a routine integral. We integrated it and equated it to 1. After first substitution, we have a nice integral. After another substitution, it is straightforward. We integrated it, substituted the limits, and equated it to 1 to get any quadratic equation in A, and we get two irrational solutions from there.